Have you ever stared at that tiny little eye on top of your screen and wondered how it was born? Not in the tech specs brochure way, but in the real, messy, factory floor way. Behind that small plastic shell that shows your face to the world, there's an entire world of engineering, clean rooms, and people in outfits that make them look like astronauts. And it all starts long before the casing gets clipped to your laptop. It begins with an idea. Somebody somewhere decides the world needs another webcam. That simple thought kicks off a whole process of design, sourcing, testing, failing, fixing, and more testing. Until eventually it's shipped off in a neat little box that you casually toss on your desk. The earliest step is design. Engineers gather around and argue about what the thing should do. Should it record at 1080p or 4K? Do we want 30 frames per second or 60? Autofocus or fixed focus? How wide should the field of view be? Will there be one microphone or two? Should it have noise cancellation? Maybe even a built-in light ring or a sliding privacy shutter. All these choices feel invisible when you're using the webcam, but each one affects how complicated, expensive, and reliable the factory line will be. A decision as small as plastic lens or glass lens changes the entire cost structure and dictates what kind of testing the line needs later. They draw sketches, fire up CAD models, and churn out prototypes that sometimes look clunky, sometimes don't even work, but at least get the ball rolling. These early units are like crash test dummies. They exist to be tortured, poked, and dropped until the weak spots reveal themselves. Those prototypes go through brutal tests under blinding studio lights, in near-dark bedrooms, against mixed light that would confuse any camera. Engineers drop them on the floor, wiggle them on wobbly laptop lids, yank the USB cables out midstream, anything to see what will snap first. Some look great in daylight but produce video that looks like a 90s webcam as soon as the lights dim. Others capture sharp, crisp detail, but start heating up like a toaster after a 10-minute call. Engineers tweak, adjust, redesign the casing, swap out sensors, try different lens suppliers, and argue over firmware fixes until the design feels solid enough to survive the chaos of mass production. Once that gauntlet of design is complete, the scavenger hunt begins. A webcam isn't built under one roof, like some neat little assembly line in cartoons. It's a Frankenstein stitched together from parts scattered all over the supply chain. The image sensor, the true eye of the camera, usually comes from a semiconductor fab that lives and breathes dust-free clean rooms. These places look more like science fiction labs than factories, with workers in full gowns moving wafers around like they're handling priceless relics. A single batch of sensors can be worth millions, and a microscopic defect can turn an entire wafer into junk. Then there's the lens, another make-or-break piece. Some manufacturers specialize in polishing tiny pieces of glass with tolerances thinner than a strand of hair, while others mold high-grade plastic into lenses that can be mass-produced at lower cost. Either way, the curvature, coating, and alignment have to be perfect, or the final image looks smeared, distorted, or plagued by ugly reflections. The microphone, often treated like an afterthought by consumers, has its own supplier too. These little capsules decide whether you sound clear and natural or like you're trapped in a tin can. And then you have the beating heart of the whole device, the circuit board. These green slabs start life as flat sheets, etched with copper pathways thinner than spaghetti, then run through pick-and-place machines that move faster than the human eye, slapping down chips, resistors, and capacitors with robotic precision. Once populated, the boards are heated in massive ovens where solder melts and locks everything into place, turning loose components into a functioning electronic brain. Watching it is like seeing a kitchen where instead of bread rising, you've got cameras being born by the hundreds. Even the outer shell, the part you actually see, is its own story. Injection molding machines take raw plastic pellets, heat them into a molten state, and inject the gooey mess into molds that stamp out perfectly shaped casings in seconds. For higher-end models, aluminum shells are milled or extruded, then anodized or painted to give that premium tech look. All of this happens across different suppliers, scattered around the globe, each running on its own schedule. If one supplier ships late, if a lens batch comes scratched, or if a circuit board line has too many rejects, the entire production line grinds to a halt. That's why coordination is everything. Assembling a webcam is less like cooking a meal and more like conducting an orchestra, where every section has to play in sync or the whole performance falls apart. Once the pieces are in hand, the factory looks less like Willy Wonka and more like a scene from a science fiction movie. Workers dress in bunny suits, masks, gloves. The rooms are carefully filtered because a single speck of dust between a lens and a sensor could ruin the entire unit. Imagine paying for thousands of webcams only to find that every single one has a tiny smudge in the exact center of the image. That's why dust is enemy number one, and everyone moves like surgeons, careful not to let static electricity or sweat or even a sneeze ruin the job. This is where alignment comes in. The sensor and the lens have to be placed with insane precision. Being off by even a fraction of a millimeter could mean your webcam focuses on the wrong plane, giving you a soft, blurry image. It's not just about putting the pieces together, it's about putting them together perfectly. The assembly process is equal parts human and machine. Circuit boards loaded with chips are inspected, lenses are assembled into little barrels, sometimes with multiple elements and special coatings. Then comes the marriage. The lens is carefully mounted above the sensor, fixed in place, sometimes adjusted by machines that twist the lens until the focus is sharp. Then lock it in place with glue or screws. If the webcam has autofocus, tiny motors are added, and those get calibrated too. Housing pieces are clipped or screwed around the guts, making sure everything lines up: USB connectors, microphones, privacy shutters. A webcam is born looking whole, but it's far from finished. Now the tough love begins: testing. Each unit, or at least a big sample of each batch, is put through image tests. Special charts with grids and color patches are held up to see how sharp the lines are, how true the colors look, whether the lens distorts edges. Bright lights are used, then dim lights, then awkward mixed lighting. The webcam has to adapt. Auto exposure, white balance, gain control. All those hidden features kick in. Some units fail miserably, showing a green tint or hunting for focus endlessly. Others pass with flying colors. Those that fail might be reworked if it's an easy fix, like reseating a lens, or else they're tossed aside. But image tests are just one part. Mechanical checks follow. Does the housing rattle? Can the clip survive repeated flexing? Will the USB connector snap off after a few uses? Stress tests mimic shipping, vibration, shaking, hot and cold cycles, humid environments. The webcam has to hold up in India's summers and Canada's winters, sometimes even both in the same week, depending on shipping routes. And then there's firmware. A webcam without its software is like a musician without rhythm. It'll technically play, but it won't be pretty. Firmware is loaded in the factory, telling the sensor how to handle noise, how to balance colors, how to compress the stream before sending it over USB. Calibrations are made so that the webcam doesn't make you look like you're sitting in a dim cave when you're just in your bedroom. Serial numbers are burned in, drivers tested, connections verified. By this point, the webcam is both a physical object and a digital personality, and both sides need to work in harmony. Only after all that does packaging happen. Each webcam gets cushioned with foam or cardboard, a manual or quick start guide tucked in, sometimes a small tripod or clip stand included. The boxes are sealed, labeled with regulatory marks, CE, FCC, ROHS, and barcodes, then stacked into bigger cartons, onto pallets, and loaded into trucks or containers. From there, they head off to warehouses, retailers, or directly to your doorstep if you ordered online. By the time you slice through the tape on your package, your webcam has already lived a long life. Design debates, sourcing headaches, dust battles, alignment surgeries, torture tests, and firmware brain implants. What makes this story more fascinating is how small design decisions echo through the whole chain. Take the choice between plastic and glass lenses. Plastic is cheap, easy to mold, lightweight, but it scratches easily, distorts more, and doesn't deliver the sharpness of glass. Glass is expensive, heavier, harder to manufacture, but gives crisp images and resists wear. That one decision changes supplier relationships, assembly complexity, cost, and ultimately what you see when you turn on the camera. Or consider autofocus, great for people who move around, but it adds motors, calibration steps, more ways for things to break, and more testing. Or going from 1080p to 4K resolution. Suddenly, your sensor has to be more powerful, your lens more precise, your firmware smarter, your USB interface faster. Every upgrade means more factory headaches. That's why not all webcams are created equal. Cheap ones often skip the fancy stuff. They use fixed focus plastic lenses, basic sensors, minimal firmware. They're fine if you're video calling your aunt in daylight, but throw them in a dimly lit room and you'll look like a pixelated ghost. Mid-range webcams strike a balance. Better coatings, sharper sensors, decent mics, sturdier housings. Then you have the premium ones, where manufacturers throw in multiple lens elements, high-end sensors, 60 frames per second 4K, stereo microphones, even built-in ring lights. Those require far more rigorous manufacturing, and it shows in both the price tag and the image quality. Factories constantly juggle yield, which is the number of units that come out good versus those that fail. High yield means lower costs and happier accountants. Low yield means wasted parts, rework, and frustration. If a lens supplier starts sending parts with microscopic scratches, yields drop. If sensors arrive with dead pixels, more units are discarded. This dance of tolerances, defects, and acceptable error margins defines how affordable or expensive the final webcam will be. And when people complain online that their webcam is blurry or has weird glare, it often traces back to a small slip somewhere along that production chain. So next time you see your face reflected on a video call, realize you're seeing the work of dozens of hands and hundreds of small decisions. That sharpness you like is thanks to perfect alignment in a dust-free clean room. That smooth autofocus is the result of tiny motors tested and calibrated. That accurate color is firmware fine-tuned after endless calibration. Even the fact that the USB plug hasn't snapped off yet is because someone in the factory yanked it 1,000 times during stress testing. The boring little rectangle staring at you from the top of your screen is actually a piece of engineering that had to survive a battlefield of design compromises and manufacturing challenges. And that's the beauty of it. We think of webcams as disposable, forgettable gadgets, but the truth is, they're the sum of years of sensor development, decades of optical design, and the daily grind of factory workers making sure dust doesn't sneak inside. It's not glamorous, but it's essential, because without all of that, you wouldn't be visible to your friends, colleagues, or live stream audience. It's a whole invisible world condensed into a single plastic shell. So the next time you adjust your webcam before a meeting, maybe give it a nod of respect. It survived the clean rooms, the screwdrivers, the test charts, the firmware flashes, the boxes, the trucks. Also, you could look slightly less tired on a Monday morning Zoom call. If you enjoyed this peek into the hidden life of your gadgets, hit that like button. Share this with someone who constantly complains about their camera quality, and drop a comment telling me what surprised you most about the whole process. Was it the dust battles? The alignment madness? Or the fact that someone literally shakes your webcam on a test jig before it ships out? And of course, if you want more behind-the-scenes stories of how everyday tech is born, you know what to do. Stick around, because there's plenty more where this came from.